Perfect. Hello, everyone. Looks like we're live, and welcome back to another episode. This time we are on with the Cambrian Hack, a hackathon by Cambrian One team, supported by Jito Restaking and Solana Foundation as well, with a prize pool of 10K USD. Apart from that, there are a lot of other unsaid benefits that goes with participating in the hackathon, which is you get to brainstorm with the team, you get to meet the team, get feedback on your project, and a lot more. But to give you a quick introduction of the hackathon, this is an online hackathon, focused on the node consensus network using Cambrian SDK and Jito. Restaking emerged as a big narrative last year, continues to attract a lot of capital in the ecosystem. But Cambrian SDK has actually simplified the development of the node consensus networks and AVS development for Solana restaking protocols. But obviously, for more, we have Gena with us today, who's the founder at Cambrian. I will pass on the stage to him, and he would be the best person to take us through the content of the workshop and just to get you building on Cambrian. Jena, on to you. Please feel free.
Yeah, thank you. Hi everyone. Welcome to our workshop on building node consensus networks with Cambrian SDK on top of Jito Restaking network. My name is Gena. I'm founder of Cambrian, and today I will show you how you can easily run an Oracle on top of Jito Restaking network. But first of all, let's talk a little bit what is restaking, how Jito Restaking is made inside, and then we will transition to building itself. So the short introduction to restaking in Solana. Restaking has emerged as a critical innovation in blockchain ecosystems about a couple of years ago. It started with a eigenlayer on Ethereum, but soon after there were Jito and Solana who explored the same narrative, and this thing allows the same stake tokens to secure multiple applications. On Solana, Jito has pioneered this approach, creating a framework for node consensus networks that coordinate validators to perform specialized tasks while leveraging the security of staked SOL. However, developing and deploying NCNs is kind of challenging due to complex multi-program interactions, different security models, significant. It all leads to significant development overhead and operational complexity. So this is what our SDK is aimed to help with. It's an SDK designed specifically to simplify NCN development and deployment. Before diving into Cambrian architecture and Cambrian workshop, let's understand the underlying Jito Restaking architecture that we will be building upon. Jito Restaking consists of two main programs. It's the Vault program that handles deposits, tokenized stake, and delegation, and restaking programs that facilitates interaction between NCN separators and vaults. So basically, what we need to set up, sorry. So the system works through a series of relationships with vaults and NCNs, and where vaults creates tickets to support NCNs, which must go through warm up and cool down processes for activations and deactivation. NCNs and operators, it's a mutual opt-in process where both NCNs and operators must explicitly agree to work together, and vaults and operators, where vaults delegate stake to operators, forming the economic basis for the system. These interactions create secure, decentralized framework where operators execute consensus requiring tasks on behalf of applications. So NCN itself, it presents a powerful paradigm for on-chain coordination. They enable, for example, decentralized Oracle networks where multiple node operators reaching consensus on external data. Some kind of threshold signature schemes require, it's when multiple parties required to sign for transaction execution, something like multi-sig, but more sophisticated. Cross-chain messaging, advanced execution environments like T and other stuff. But as I have already mentioned, implementing those involves numerous challenges, like setting up the proper on-chain accounts, managing operator communication, coordinating consensus mechanisms, handling stake and rewards, and many other tasks. Without specialized tools, developers must navigate complex program interactions, create custom infrastructure, and manage intricate state machines. It's a significant barrier to entry. So, given all the above mentioned facts, let me introduce you to the Cambrian platform. It's a comprehensive platform designed to eliminate those barriers. It provides a standardized framework for building, deploying, and managing NCNs on Solana and Jito Restaking protocol. Our platform aims to simplify development, providing high-level abstractions and tools, standard patterns, offering like battle-tested templates and components. It accelerates development by automating infrastructure setup and configuration, and enhances security by implementing the best practices by default. By using our platform and SDK, developers can focus on their application logic rather than the complexities of Jito Restaking infrastructure. So, what this platform consists of? At its core, there are two main components for now. I mean, the ones that we will be using during this workshop. It's a Cambrian consensus program, which enables registered Jito operators to execute specific on-chain instructions called proposals. And for execution, the signer must be registered as operator, and linked to this consensus state, it must have sufficient delegated stake, and the proposal must receive approvals from enough operators to meet the threshold. And this creates a secure, decentralized decision-making mechanism for your application. For now, it's a proof of authority type consensus, but in general, we have a pluggable consensus mechanism with other types of consensus on the way. What next? And the Cambrian Oracle program, since we will be showcasing the creation of a simple Oracle. Oracle program standardized how operators feed external data into the application. It can so operators can update Oracle data through various methods like streaming, schedule runs, on-demand runs, and so on. It has a secure on-chain storage, and operators can consume data through standardized interface from the storage. Together, those components provide the foundation for building sophisticated NCNs with a minimal boilerplate code. So, let's start the workshop. I will show you how to build a simple Oracle that provides us with the current date. It will be up and running in DevNet in like maybe next 10 to 20 minutes, depending on how many errors we will encounter during the thing. And everything is done using the Cambrian CLI utility, which should be installed at first. But first, let's check the let's switch to the terminal and log in into my test box. Let's check the node version. Seems okay. And let's install the latest client. All these guides on all the guides how to install the CLI and how to use it, they're available in hackathon docs, so please refer there. If you have any questions, you can visit our Discord and ask them there. Guys will be providing Discord link in the end of the workshop. It's also the hackathon, so yeah, we are waiting a little bit while it installs. Okay. Looks like we're good. Let's check the version. Yep, it's the latest one. Now let's make the directory for demo and name it like demo. Let's go there, and first of all, let's create the new AVS using the Cambrian CLI. Use camp init -t AVS and name it like demo AVS. Why not? Here we can take all the defaults. It will the EVS is created in the devnet, of course, not in the mainnet. It can create all the keys. For storage key, let's say demo, and 3 operators for consensus threshold. All parameters seems okay. So now it started working. Under the hood, it goes to Jito. It initializes all the moving bits and pieces. You can see it in the in our docs what is done under the hood, or you can ask us to let you in the repository to see the code itself. Generally speaking, we do all the needed mechanics to run to set up and run the Jito NCN. So now we can see available EVSs, and here it is. And let's run it. And EVS run over. Okay, so we have started the EVS. It has 0 operators connected, and we'll go to the next CMUX window, go to the demo, but first let's check how our Docker container for updates is called. Let me check how it's. Okay, I'll do it. I'll do it different way. Mm. Mm-hmm. Here it is, Oracle update, current date. Okay, so it's time to create the 3 operators that will be running getting the data and running the proposal. Camp init -t operator is used to create operator op0. Yes, again, all the defaults are working. We'll use a container stream. Image for the container is like this. No additional elements, no environment. Default and admin private key. Admin private key can be looked up in a configuration file because we haven't specified it explicitly. Let's go there. Let's create a new window. And here it is. We've created operator 0. Now it's time for operator 1 to be created. Basically, we repeat all the steps. Admin private key. Okay, so it's in the game. And the last one. Okay, the last one in there. So it's time to run them all. Well, by this command, we can list all the operators that are registered for the given AVS. Let's take this one and say camp meter run. And now if we will go to the EVS log, we will see that it has the operator connected. Camp EVS. So let's run them. This one, camp. Copy the last one, create new window. Camp operator run. So the last one in there is there. Let's see. It's operators log. Yeah, we have 3 operators connected in EVS. It started storing current timestamps, and now we need to see that it is actually working. How can we do this? We can do it in this way. Camp EVS list. And here we go. Let me see what's happening real quick, because it looks like something just went wrong. One sec. Okay, they seem to be sending the required things. Let me try it. 1 second, it happens. Okay, probably we're calling something wrong. Okay, let me think a little bit. Probably I can go to different host and let's restart everything. Okay, let's wait while it stops and start again. Camp. AVS list. Okay. Minus a list specific operator. Operator. Yes. So the first one. Let's remove this container and start the operator. What we are doing now is we essentially removing the containers that were being used during the first run to run everything in U. I'm trying to work around the the thing that we got in the middle of our demo, because we're running on DevNet and everything can happen on DevNet. Not container. Operator. And the same thing with removing a container. And run it again. Okay. And hope it will work. Nah. Okay. As they say, third the charm. Let's do it once again, trying to update with update of operator containers. Okay. So that's docker -a. Let's kill all the Docker containers. Maybe they're of incompatible versions because it's not really a clean environment. Okay, so everything is clear now. So Cambrian Camp. So we're re-downloading all the containers that use this EVS and this operators. Okay, so it's there. Let's list all the operators. They have the same keys. We will add the -u for it to update the container. Okay, all three are in place. They're sending some data. Let's wait a little bit. Okay, so they have and here's the moment of truth. Here goes. Ah, seems like I forgot one important thing to build the image. It happens when you're not really a smart guy. Okay, so it's there. And here goes. Well, I can't believe it. We made it. It actually works, and we can see there all the votes, all the data. all the everything. So if you will follow this on a clean machine, and since you're obviously smarter than me, you will do it not in 30 minutes, but in 10 minutes at most, instead of a couple of weeks at least required to build this thing on top of Jito NCN. And given this, thank you for viewing, and let's see if there are any questions. And in fact, there is. What is the minimum system requirement to run the Cambrian SDK? It actually depends on how complex is your is your container that streams values and everything. But for example, for this example, for this demo, I used a rather small development box with something like maybe 2 gigs of RAM and 1 processor core, something like this. So they totally depend on what kind of containers are you going to. And Idika, seems like there are no more questions there, and we have successfully finished the thing. We will check if the documentation, our docs reflect all the pain that we have suffered while doing this now. But in general, thanks for watching, and drop me a line if you want on our Discord.
Thanks a lot, Gena, and thank you everyone for attending. That was it. If you by any chance missed the live stream or any part of it, or you want to recap any part of it, like I said, they would be available on the workshop tab on the hackathon page on DoraHacks. So feel free to, learn at your own pace, go back to it while you're building. And another thing that I would highly recommend is do not forget to join the Cambrian Discord. That is another place that you can get your questions, talk to the team, meet fellow builders, potentially also find a teammate to build with, and a lot more things. Just brainstorm together over there, drop your ideas, etc. So do not forget to join the Discord. The link is in the comments. But yeah, that was it from our side. And just again, as a reminder for everyone, we wrap up the hackathon on 16th March. That would be the last day of submission for everyone. And the winner announcement would be done on the Apex Cape Town event on 28th March. So a lot of exciting things coming up. And if there's any question regarding the submission or using the platform in general, feel free to hit me up at Mishika, MISHIKA251 on Twitter or on Telegram. I'll be happy to help you or connect you with the right folks. But yeah, that was it. And thank you everyone for attending. And thanks a lot, Gena, for walking us through and taking out the time today.
Yeah, thank you so much for having me. Hit me up on the Discord if you have any questions. I'll happily answer them. See you guys on the stage.
See you everyone. Bye.
Bye-bye.